Hey you guys, welcome back to the channel PHYSICSSIRJEE, and you are in Resolved series, and today we are going to resolve a concept that's a part of JEE Advanced syllabus brochure, but it's not taken up in NCERT textbook, or it is not existing in the NCERT lab manual. Okay, so this is something that troubles the students, and it's an easy concept if it is understood very well, because it relies on something which is familiar for you from meter bridge. Okay, so this is post office box in physics experiments. Okay, so as you could realize, the naming of this is a post office box because in olden days they used to actually use this to communicate. It was originally called British post office box because Englishmen used to use this during World War telegraph communications. Okay, so let's go ahead and try to familiarize ourselves with this concept, and then try to see some illustrations to apply that concept, and also see how many times JEE has asked questions in the past on this particular scenario. Okay, so let's move ahead. Try to stay till the end of the video. As is the case with any resolved series, we will try to finish those several illustrations, and then I'll give you a problem for which I'll give you solution few days later. Okay, so the basic picture of any practical post office box looks like this. Okay, so the left hand side diagram is something which is called a 4-arm post office box. Okay, so you could see there are 4 arms, 1, 2, 3, and 4. Okay, and whereas a 3-arm post office box would have just 3 of them, it looks like a shape of S. As you could see in the thumbnail itself, I have shown it. Okay, so the one that is on the rightmost, the depiction of it in a question paper or a circuit diagram would be on the right. Okay, so the middle one is the practical look of that post office box, and the right one is the circuital diagram or representation in a question paper. Okay, so this is the idea. So 3-arm or 4-arm, the S letter that you usually see in question papers is because they are trying to refer to a 3-arm post office box. Okay, what are these keys here and here? What is their function? What are these numbers? We'll try to understand as we move along in this particular tutorial. Okay, so let's move forward. The first and foremost, let's try to understand what are these important terminals, and you should realize that the working of a post office box relies on a balanced Wheatstone bridge. So something that rings a bell in your brain should be that it is a concept similar to the working of a meter bridge. So you all people should relax that this is not a new concept. It's just an apparatus which is certainly looking new to you, but it is on the basis of working of a meter bridge. Okay, so once it is a meter bridge or a Wheatstone bridge, you will have a diamond shaped structure of a circuit in your mind. So we need to identify which are those terminals that are in this particular practical picture that pertain to that diamond shaped structure of a balanced Wheatstone bridge. Okay, so as I have already marked here, this terminal is A, and this is B, and this is C, and this is D. So with that A, B, C, D, let me draw a diamond shaped structure here. Okay, so this S-shaped structure in exams will be given as this S-shaped structure. You could see this A is marked here, B is here somewhere in the middle, and C is here, and then D as it is here. You have keys here, right? K1 and K2. Actually, this K1 is also called as A prime or A1. And this is actually underneath connected to this particular A. You don't see a wire connecting these two, but under the box, there'll be a wire which is connecting to this, which means in order to connect to A, you actually connect to this entire thing. Okay, so there's a key here. If you press this down, the connection would be made. Okay, right? So this itself is nothing but A. So they'll consider this as A prime, a substitute for the point A. They don't want to make wirings here, here, or here. They'll try to do it from here. So the wire is underneath connected. And how do they show it in the question paper? They show a dotted line between that. Okay, so this is like a wire which can't be seen, and it's inside the box. Okay, so that key K1 is here. Similarly, B is connected to a B prime or a key K2 that is written here. In textbooks, they'll be also writing it as B1. C is just alone, and C is usually remembered as a letter that is connected to cell, C for cell. Okay, but there is no standard rule that in an exam they can interchange these alphabets. It's all about identifying how these letters pan out in this scenario. Okay, so you could see that I have put A here, B here, then C here, and then this D is here. Okay, and between B and D, that is this B and this D, where is this B here? The B is here, right? So between these two, you can actually mark, or you can actually connect a galvanometer. You could see that B is here and it's connected to a galvanometer to D. Similarly, between C, which I said, remember it as standing for cell or the rightmost point, that standard connection to A is already here. Remember, these two are connected. So C to A is directly connected with a cell, and that you could see here. Okay, so you have now a Wheatstone bridge. This is said to be balanced if the resistance between A and B, represented by this number somehow, I'll call it as P. Okay, and resistance between B and C, which is represented by these numbers, is called Q. If this P by Q is equal to resistance between A and D, where is A? A is all the way here. These two are A's, okay? Right, remember, this is A, and even all of this is A. Okay, so between A and D means all these keys come into picture. So the two arms of this post office box correspond to a resistance between A and D. Okay, right, what's inside these keys and all, we'll try to ascertain. So that would be called as a standard resistance R. Okay, right, and then the value of S is usually associated with a unknown resistance. So S is to be found out. And we'll try to adjust these numbers during the experiment in such a way that the P by Q, which is the standard ratio of these resistances, will be managed to be equal to R, which would be a known value but a variable resistance, divided by S, which is an unknown value but a constant resistance. Okay, so S is to be found out in this particular experiment using a galvanometer deflection. So just like meter bridge, this particular experiment relies on null point deflection. Okay, so now let's move forward and try to understand what these keys are and what are these buttons, and how the resistances between these two, A and B, B and C, and A and D, all these things can be varied, and what's the importance of these numbers 1, 2, 2, 5, 10, 20, 20, 50, etc., etc. Here there are only multiples of tens, but here you have single digit, double digit, triple digit, and 4-digit numbers. But specifically, you could see that it's associated with 1, 2, 2, 5, and their multiples. Okay, so let's try to understand that. So in an exam paper, they will try to give the same thing in this format. Can you see the same yellow color structure? It would be very difficult for examiners to draw this in your computer-based examination. So in case they ask, they'll show it in this direction, right? So this is what you are supposed to be familiarized with. Suppose I want this capital R, which is the resistance between these two arms, A and D, right? I already told you this is A and D, to be, let's suppose, 2794. Just like our childhood way of writing 2794 in thousands place, hundreds place, tens place, and singles place. Okay, so 2000 plus 700 plus 90 plus 4. Okay, so in order to get 4, we'll try to use this single digit resistors. The idea is the particular keys that are there, whenever you go back, right, this key would be like a short circuit. If you don't use this key, that means you pluck it out, then you use this 1 ohm resistor. Okay, but if you don't want to use 1 ohm resistor, you put the key in. Right now in this position, this key is put in, then there is a short circuit. That means this 1 ohm is not being used. Similarly, for 2 ohm, if this key is inside, then the 2 ohm is being not used, and if key is pulled out, then 2 ohm is being used. Okay, so in order to get, let's say, 4 in the single digits place, you can use the 2 and 2. 2 plus 2 is 4, right? And that means you don't want to use, let's say, 1 and 5. Then you put the key into that 1 and put the key into the 5. So let me show you how he can makes that in the examination. So in the examination, he can just try to give a cross mark or something like this. So I don't want to use 1 and I don't want to use 5. That means the keys are in, and you plugged out the keys from 2 and 2. That means 2 plus 2 are in series, therefore you get a 4. Similarly, in the tens place, I want a 9. That means 90. So in order to get 90, I can use it as 50 plus 20 plus 20. That means I want to use 50, 20, and 20. Therefore, I don't want to use 10. So I want to short circuit 10, which means you just put a X mark here. That means you have put a key into that. Similarly, 700, very quickly, 500 and 200 can be used. 100 should be short circuited. 100 is corresponding to this, right? So this is 100. You don't want that 100. So this is a cross mark. And this 200, because of the print, they have gone to that side. So this 200 is here. You don't use it. Okay, right? And this 200 you use, and this 500, remember, this is 500. Okay, so, and this is 200. Use both of them. And this 1000 that you have here, you don't want to use it. Okay, so just like that. So 500 plus 200 will give you 700. Then you want a 2000. I think you can directly use this 2000, right, which is here, right? And 1000 you don't want to use, 2000 you use it, and this 2000 and the rest of the things you don't use. Okay, right? So that's how you get 2794. And why do you want to use that? We'll try to get to that. So thing is, when you want this as 2794 and you can maintain some ratio for R1 and R2, let's suppose this is R1, you make it as, let's say, then if I close these two, that means 110 are not being used, you are using 1000, that means R1 is 1000. And let's suppose I use 10 but I don't use 100 and 1000 here, R2 is 10. Therefore, in this particular problem, the value of R1 divided by R2, which has been 1000 divided by 10, which is 100, should be equal to the value of R divided by X. So the value of X, if null deflection is found out, should be equal to capital R divided by 100. Okay, that's the advantage. So using these integer numbers, now you can maintain the value of X. Let's say the unknown value is R by 100. You'll be able to ascertain that value up till second decimal place. So you can say that this value of X under zero deflection, all this should happen when diameter, galvanometer is showing zero deflection when key 1 and key 2 are closed. Okay, that's how any meter bridge or a Wheatstone bridge balance occurs. Okay, so that's how you ascertain this. So we can see by varying the ratio in the standard arms, this upper two ratios are called, upper two resistance ratio is called standard arm ratio, and you can make it 100 or you can make it 1 by 100. You can see, you can keep manipulating, and therefore you can either get the values which are very low by getting 100 below. Imagine I made this 1 by 100, then you can measure it up till 100 times of this also. So that's the advantage. Okay, right? So this is the basic functioning of a post office box, similar to a balanced Wheatstone bridge. So let's try to move forward and see how JEE in the past has asked a question. Okay, so this is only one and only JEE question till now that has been asked, but there's no guarantee that they'll not ask. For the last 15 years, they have not asked till now. Okay, so for the post office box arrangement to determine the value of unknown resistance, the unknown resistance should be connected between. I think we have seen already that if these letters are there and these dotted lines should represent the wires underneath, these are key 1 and key 2. Okay, so he's asking if this is your Wheatstone bridge with this as standard arms, and remember this is the resistance arm that you have with those 1, 2, 2, 5 and all that stuff. So then you should be able to reproduce the Wheatstone bridge and then ascertain between which terminals the answer should be written for the unknown resistance. In some other exams they will actually give it like this, so don't worry about what these things are. These are just a way of representing the keys. Okay, so key down, you have to press it down, that's what they are representing. Okay, so let's see the solution for this. You want to give it a try, pause here, try it out, and then we move forward. Okay, so this is the solution for it. So the unknown resistance X is to be connected between A and D. Okay, so, and that's very simple. You have to just draw this diamond shaped structure, mark all these points effectively. Remember, this is R1, this is R2. So the C is common point, always remember, for R1 and R2. Put C on the top. So B is here and D is here, and then A is on the other end of the B. So B2A is the longer resistance. So this is the standard known resistance. Okay, right, that you can adjust by plugging in or plugging out the pins. Okay, X is the unknown resistance which is to be connected between, therefore, A and D. So you go back and mark the required answer as A and D. Okay, so the answer should be A and D, which is option C. Okay, right, let's move forward. Right, now let's try to understand how these keys work. Okay, so they can ask a question on what's inside that key. When you're pressing it, they're saying it's a short circuit, and when you're opening it, you're saying that the resistance is being used. Okay, so identify which of the following diagrams represent the internal construction of the coils wound in a resistance box or a PO box, it's not PQ, it's a PO box, post office box. Actually, there's another thing called as resistance box, where you use that as a variable resistance that you can use, and that also this kind of pins will be there. Okay, so he has given some structures where you can see this is the pin. If you lift it off, then this part to this part, if the current is flowing, let's say like this, if the current is flowing, then if you have this connection, right, the pin is closed, then the current has a path to move in this direction. So that means it will not enter this resistive path. This is the resistor, or this is the coil which has resistance. So when, that's why we say when the pin is closed, it's a short circuit. Current will just go straight. Now when the pin is lifted off, current has to pass through this entire wire and come out of this in this manner. So how should the shape of the coil inside in four options that he has shown should be connected in order to be in order to be a part of the post office box? There should be a reasoning why all these wires are different. Okay, so just pause it, try it out, look closely, zoom the picture or something, and then maybe I'll zoom it for you, and then you will try to answer it. Okay, so right. Okay, right. So let's see the solution for it. Answer is actually D, and D is something that you should understand. So D is something that you understand should be the answer. So let's try to see why the coil wiring should be like this, and what is it doing? The coil wiring is going inside like this, and then while coming back, it exactly matches with the each of the going in wires in reverse. So what's the effect of this? This kind of effect you see generally to cancel the inductive effects. Okay, why do you have inductive effects? Please understand, whenever the currents are flowing in this, when you pick out a pin or keep a pin inside, you're actually making an open circuit into a short circuit and short circuit into an open circuit. Sudden changes in current will start happening through galvanometer, and then there will be inductive effects. You don't want these inductive effects. That means effects produced due to magnetic field and its variations. Current carrying wire will produce magnetic field. So if you can make sure that the coils are double wired like this, that means wherever entry of current goes, when the current is coming back to exit, it should be exactly cancelling out, so that the magnetic field produced by such double wired coils should be zero. And then if B itself is zero, then dB by dt won't exist, and therefore the rate of change of flux and inductive effects should not affect your galvanometer deflections. Okay, so that's the idea that we need to pose. Okay, so that's why when the key is closed or key is opened, the currents, when they are flowing, they should not have any induction effects. So that's the reason why the answer should be option D. Okay, so option D is the correct answer here. Right. Next one. Another question, you want to read it on your own, then apply concept and go ahead. You pause the video here, study the problem on your own. This is one or more than one, and then you can go ahead with the solution, and I'm going to explain. Okay, so let me read it out with you. When we operate a Wheatstone bridge, then in starting, the key of the battery is closed first, and the key of galvanometer is closed later. When the circuit is to be closed, then switches are released in opposite order. Okay, right? Why? So the options are, look at the diagram of the PO box from the previous pages. The switch is the switch off battery. Okay, so this should be switch off battery is always on the right hand, hence it is easier to press first. Okay, so he's saying that key 2 is on the right side, so it's easier to press because most of the people are right-handed. This is done to avoid the damage of galvanometer due to induced EMF. If the galvanometer switch is pressed before the battery switch, then large sparking takes place at the battery switch. Option D, while disconnecting, if we open the battery switch before the galvanometer switch, then we can observe induced current in the circuit till the galvanometer switch is opened. Okay, so these are the four options. You have to identify which of the four is correct in order to explain the statements that he's talking about. What are the statements? When you are starting, you have to close everything, right? The closing order, according to him, remember, the closing of switches order is battery first and then galvanometer. Galvanometer always comes later. And the opening, that means you're done with your experiment. And he's saying the order of the opening of the switches is galvanometer will be opened first and then batteries will be opened. Okay, right. So that's what he's asking us to explain. I think you might have, now I'm going with the solution, you might have already realized that it has to do with the induced EMF, just like your coil winding that you had yesterday in the previous question. When the key is being done. So we are very much worried about fast changes in currents when you're plucking out pins, opening and closing switches. Okay, so you should be very careful. So the solution that we need to go about is that I have pasted the options here. Okay, so I would say option A is nonsense. It's not about right hand, left hand bias. I think option B is definitely correct in order to avoid the induced EMF effects in the damaging of galvanometer. Okay, so the thing is, you should realize that the galvanometer should not be in connection whenever changes of currents are happening. So when you're closing the switch, imagine you close the galvanometer already. Okay, and galvanometer is part of the circuit, current won't flow then, no issue. But when you close the battery, immediately sudden change in current happens, and galvanometer, there will be a coil and there will be induced currents, and your deflections and damages will happen. So that's why when you are closing, always close the battery first, okay, and then the galvanometer. When you're opening, again, if you open the battery first, galvanometer is still in the circuit. So whether it is closing or opening, the thumb rule is galvanometer should not be a part of the circuit. Okay, right? So that's the idea. So the option C, if galvanometer switch is pressed before the battery switch, pressed means you're closing it, then it is ready for the circuit, and then you close the battery, then the galvanometer will start having di by dt's or dB by dt's. That's the problem. Okay, option C. And while you're opening the switches, that means the circuit is running right now and you want to open, please open the battery galvanometer first. If you open the galvanometer, nothing will happen. But if you open the switch, again, current from high value is reducing, again di by dt will be there. So thumb rule is avoid di by dt. Rate of change of current you should avoid. Okay, so option D. So answer should be B, C and D. Okay, right. So let's move on. This is another question. Again, pause, read the question on your own. This is how the picture will be in your examination, and then try to see one or more than one may be correct, and then go ahead with the solution I'm explaining. Okay, so if by mistake battery is connected between B and D, remember battery is actually supposed to be connected between the B and actually C, right? B and D, and galvanometer is sorry, battery is to be connected between A and C, and C is for cell, you remember, and galvanometer is to be connected between B and D. They are interchanged. The connections of galvanometer and battery are interchanged. Then which of the following are right? If only key 1 is pressed, that means this key 1 is connected to A, remember, is pressed, there will be no deflection in galvanometer. That statement is over. Second one, if only key 2 is pressed, then there will be no deflection in galvanometer. Option C, experiment can be done in similar manner, but now key 2 should be pressed first and then key 1. That means whatever pressing order that he told us in the previous problem, the pressing order of keys should be reversed, he's saying, and experiment is fine. You can interchange the positions. Option D, without taking out any key from the plugs in the arm AD, remember arm AD is this long arm, if key 1 and key 2 are pressed, the galvanometer will not show any deflection. Okay, right? If you don't take any plug out of it, that means all the plugs are closed, and then you press the key 1 and key 2, then galvanometer will not show any deflection. So these are the 4 options. Okay, right? Let's move ahead with the solution for this. So the idea is you should realize that if I have the normal Wheatstone bridge, the B and D was galvanometer, A and C was the cell, right? Remember? Now you're interchanging this BD to let's say the cell, and AC is the galvanometer. So balanced Wheatstone bridge condition was P by Q is equal to R by S is X, right? You can rearrange. Remember, you bring R down and Q there. P by R is equal to Q by X. That means the branching will just exchange their ideas, and then you would still have a balanced Wheatstone bridge. The issue is not the problem here, right? The problem is the order in which the keys are placed. Remember, the key K1 is connected to B already, but the B now is a part of battery. So whatever you have remembered from the previous condition, the order, right? So if the order B to G was all about key K2, and this is K1, this is the order, right? Now the order is not about key 1, key K1 or key K2. It's more about di by dt should be avoided. So whatever order you got in the previous problem, because the connections are interchanged, the order of this key pressing also should be interchanged. So same function, you just make sure you avoid di by dt's. Okay, so with that spirit, let's try to read the options again. So if only one key is pressed, please understand, if you press only one key, that means, let's say you connect galvanometer but you forget to connect battery, it's not a powered circuit, so galvanometer will not show any deflection. That's correct. If only key 2 is pressed, what does it mean? Galvanometer is not part of the circuit and the cell is part. I think series parallel will continue, but galvanometer should not show any deflections. I think option A and B by basic Kirchhoff's law is correct. Okay, it's not part of the experiment, but it's just something that he's checking. Experiment can be done in similar manner, but now the reverse of the keys order should be followed to avoid di by dt. So C is also correct. Now D is a tricky one, but doable. Without taking out any key from the plugs in the arm AD. What does it mean? If someone says all the keys are plugged in, that means it is a short circuit. That means A to D resistance is a short circuit. I think once it is a short circuit, this will become an unbalanced Wheatstone bridge. Remember, if R is either 0 or R is infinity, then you cannot have a balanced Wheatstone bridge with finite values of P, Q and S. Therefore, in that case, galvanometer will show definitely any deflection once the both keys are pressed. So D is the only incorrect option, and D is something which is he's checking your patience about Ohm's law and Kirchhoff's law. Okay, so answer for this particular question should be A, B, and C. Simple. Okay, let's move to another one. For a post office box, the graph of galvanometer deflection versus resistance R here is the pulled out of resistance box. That means you are plucking out a key. That plucked out resistance is being used, please understand. Okay, if you put the key in, it's not used because it's a short circuit. The ratio of the top P's to Q is given as 100:1. Okay, as shown in the figure, right? So the graph is drawn between the deflection versus the resistance, and the ratio of P's to Q is 100:1. A careless student pulls out two non-consecutive values of capital R. So when he's checking, what he does is he pulls one resistor out, another resistor, and he keeps checking the galvanometer deflection. Whenever galvanometer deflection reaches 0, then you would say the bridge is balanced, and you will then calculate the value of capital R and use this balanced Wheatstone bridge ratio and get the value of X. That's a procedure. So this careless student, in order to actually, he has to go step by step, one by one consecutive, then the galvanometer reading slowly goes to 0. But here he plugged out, let's say, 2 pins out of impatience. Then from positive deflection, the answer goes to a negative deflection. He missed the 0 deflection point. So he got this point on the graph and this point on the graph. Help him find out the unknown value from this graph. Okay, so you want to try it out, just pause the video here, try, and then move forward. It's a very simple question. Okay, now, so the solution is, you should realize that when galvanometer shows one side deflection for one value and the other side deflection for another, you should realize, because it's a continuous function, the deflection 0 should happen in between. Okay, because +5 and -3 deflection divisions, it should show up that way. And this is a straight line graph. It's as good as asking what is the x-intercept. Remember, x-intercept of this is the value of R for which he should have got 0 deflection. Okay, so using R1 by R2 should be R by X. Therefore, X should be simply R by 100, because he has given in the question that the ratio of the P is to Q, or R1 is to R2, is 100. Okay, right. So R by 100. So our idea to find X is find R, which is the intercept, and divide by 100. Simple. So to find this R intercept, equation of line passing through this point 320 comma 5 and this point, which is 326 comma -3, I'll use the 2-point form, y minus y1 by x minus x1 equal to y2 minus y1 by x2 minus x1. We need x-intercept, right? Put y is equal to 0, substitute, get the value of x. X value comes out to be, this is small x, which is capital R, remember. I get this. Then to get capital X, I divide by 100. So that would be 3.20 plus 1 by 15, which approximately comes out to be 3.206. So the answer should be C. This is how he is able to estimate that value, even though he made a mistake in the experiment. Okay, but he has to go back and check this one to ascertain whether this is, assuming this is a linear function. Please understand that. Okay, right. So perfect answer for this particular question is this. Asking none is a forbidden one. You should have given some other value here, because some people might argue that it could be something better than this. So just ignore this none and then think of it as only three options given, and out of the three, the best possible answer is C. Okay. Next one. Right, we have reached almost last two questions. So what is the maximum and minimum possible unknown resistance X, which can be determined using the post office box shown below in the figure? Okay, so the figure is, if you carefully observe, the arm is reversed. Can you see? He will try to manipulate you by, remember 1, 2, 3, 4, 5 was on the top and hundreds were and thousands were on the bottom. He can play with you like that. It's something very simple. Okay, so he's asking you using this four-arm post office box. You can see there are four arms this time. What is the highest value of X you can measure, and what's the lowest value? That's the question. Okay, so try to pause, give it a fair try, and then move on to look at the solution. Okay, so first and foremost, why 1, 2, 2, 5? Okay, so this combination of numbers gives you all numbers, okay, between 0 to 10. Can you see that? You want 0, plug all the things, okay, short circuit everything, you get 0 ohm. You want 4 ohm, then you can use 2 plus 2. You want 8 ohm, then 5 plus 2 plus 1 will do 2. So this is a combination. That's why they use 1, 2, 2, 5. And there's another pair that is used in some other countries, which is 1, 2, 3, 4. 1, 2, 3, 4 is also another combination. But if you try 1, 2, 3, 5 or something like that, some resistances you can't. So this is not a useful combination. So these are the two famous combinations. Mostly in labs that you'll find in CBSE schools, you'll get 1, 2, 2, 5. Okay, so both of these give you all numbers between 0 to 10. So now multiples of these will give you all numbers between 2 digits. Okay, and then so on and so forth. That's the idea. So just let's move on to the solution for this. Now I've just diminished the diagram, and we'll discuss about the extra point, why the galvanometer requires a shunt here, okay, which was not there in the previous problems at the end of the problem. So the question here is that the value of R1, in one of the cases you can use, right? So this R1, you can use 1110, right, by using all of this, and R2 you can use only 10. So the ratio you can go up till is actually 111. Okay, but they generally don't encourage the ratios to be something of that sort. Encouragement is usually for multiples of 10. So even though I have written it here, I would claim that the highest ratio of R2 by R1 is 100 and the lowest ratio of R2 by R1 is 1 by 100. Okay, so that's the reason why you don't use 111 for the standard ratio, that is this top ratio. Now coming to the value of X, therefore X max would be using highest value of R2 by R1 and highest value of capital R. What is capital R? The resistance between that long arm A to D, right? So all these big arms that you have. So now my job therefore boils down to finding out R max, multiplying it with 100 and saying that's the highest I can measure, and finding R minimum between A and D and dividing it by 100. Okay, so let's go to the next page to find out what's the highest value of R and lowest value of R. So I just borrowed the requirements from the previous picture here. Okay, so X max and X min is related to R max and R min in this manner. R minimum, I think, is when I use only 1 ohm. Don't use 0 ohm. Please understand, if you short circuit everything, you will always be having an unbalanced Wheatstone bridge. So the minimum value, it should be a minimum positive value. So 1 ohm, obviously. So substitute 1 ohm. 1 divided by 100 is the least value. Therefore, you can get X value least that could be measured is 0.01. So this should be 0.01 in that special experiment. In the max experiment, that is maximum value, R max can be obtained by using all the resistors, everything you use. That means you plug out all the things, all the pins you should remove. That means all of this will become series resistors. So 1225 gives you a 10. 10 20 30 sorry 10 20 20 50 will give you 100. So you'll get all the possible digits with like this. Okay, so you have 5000 up till 5000, right? So then you'll end up having even 10,000. So the addition of this R max comes out to be 4 ones and a 0 ohms. And 4 ones and a 0 ohms when multiplied with a further 100 measures the capital X max. So the value of capital X max is 4 ones and kilo ohm. So combining these two as the required answers, I think you will realize the best option that is given in the question is the option B. Okay, now coming to the extra point, why you need a shunt for the galvanometer. In some of the textbooks they will try to emphasize this. Is imagine even after telling people that you should press the order of the keys in a certain manner, right? Remember, di by dt should be avoided. Let's say one person makes a mistake, a student makes a mistake, he forgets out of nervousness. The galvanometer should not pay the price for the mistake of a student. So they put a shunt initially. There will be a switch here also, so that even by chance, let's say the current starts flowing unnecessarily high values to galvanometer, first they move through the shunt. So only after you ascertain as a teacher or a lab assistant that that student has connected everything, then they remove the shunt so that the galvanometer can show proper deflections. If you don't remove the shunt, then there will be a problem. Even when it is non-zero deflections, it might show a zero. Okay, so initially put the shunt so that galvanometer is saved from di by dt, and after that you have ascertained, always before taking zero deflection, remove the shunt so that galvanometer is on its own and it takes the zero deflection and shows you correct readings. Okay, that's the importance of this shunt in case he asks in a theory question. Okay, right. Then this one and last one. So in a certain experiment, if p by q or q by p, please read it carefully. He has given it as 1 by 10. That means this by this is 1 by 10. So this is 10:1. If the value of capital R is 192, then we are getting deflection of galvanometer towards right. And at 193, it is again towards right. At 194, if the deflection goes to left, then the unknown resistor should lie between. This is, I think, very straightforward question that I wanted to finish our discussion with. Okay, so pause, do, and then move. Okay, so this is the solution. This is 10:1. Remember, p by q is 10:1, so r by x is also 10:1. So x is therefore whatever you get for capital R divided by 10. If you write it down, it's very clear in that manner. So answer should be of the orders of 19.2, 19.3, 19.4, but none of these give zero deflection. So let's write it down. For a 19.2 you get right deflection, 19.3 you get right deflection, 19.4 is left. Therefore the zero should have lied between these two. That means the value of capital X should lie between these two. So simple answer. You need patience. You should not worry about post office box anymore. They will ask very easy questions if at all it is going to come. Okay, so by chance they try to ask a difficult question, they'll give you comprehension, slightly lengthier one, in this manner. So this is the problem that we are going to deal up in the PHYSICSSIRJEE originals in the next video. So actual use of post office box, and it's a very practical use, please understand. And IIT usually produces problems either in modern physics or electrostatics or magnetism where there is some practicality associated with it. I told you British post office box is used during war times to see where there is a damage or something has to be done during a war, right? So what actually happens is in war situations, there will be a telegraph wire which is underground cable, and if a tree or something has fallen on that underground cable because of some blastings that are happening during the war, the cable gets damaged and it gets grounded. Underground cable will have an insulation, and if that insulation gets damaged, then it will actually get grounded, conducted through the wire. So the information from one office to another office which needs to pass through that cable will get affected. Okay, right? So they need to know where the fault is, and remember the cable will run for hundreds of kilometers, so they can't dig the entire one. Post office box, by sitting in one of the offices, can be used to determine at what place that fault has occurred. Okay, it's very standard rule. So try reading this question. There are one or more than one options given to you, right? And it's not very easy, but once you draw the circuit diagram, it would be very, very simple. Actually, this is a two-part question. I made it like a comprehension. So answer this one and then take this up, which is the continuation of the previous question, and I will try to put forward the video of this in the upcoming days, okay, before your JEE advanced exam. Okay, right? So that's it. If you want to go through more resolved series and also the rest of the series which are pertaining to 100 and above videos, 95% of them are associated with JEE advanced level concepts, and most of the concepts would be something which are new, usually not part of your NCERT textbook or explained very clearly in NCERT textbook. So if you're going through, I would suggest you just put the videos in the loop and try to listen to them, so that something might click in the last part of your preparation that would be helpful for your acing of the JEE examination. I bet you would definitely not regret going through those videos. Okay, so all the links of these playlists are in the description below, so just run one playlist after another. And in case you have liked this video, it was a lot of effort bringing forward this kind of a video. Took me a lot of days to actually compile all this and do it. So please do give a like. It goes a long way in YouTube algorithm recommending this to more and more students by the weekend before the JEE exam. I wish to reach as many students as possible, because I think the sources of post office box are very less on the internet, and even those I feel are not going to give you complete analysis of what is required for JEE Advanced. So please do make sure that you pass it on, and one way of doing it is share it directly, and also like it so that YouTube shares it with others. Okay, and please do subscribe to my channel. I would request your friends to subscribe to my channel. Try to share it in Telegram groups and WhatsApp study groups, so that this video can reach and my channel can reach as many people as possible, so that I can help out as many of them. Okay, so and that will indirectly help me also in getting more and more subscriptions to my beautiful channel. Okay, so thank you very much. See you in the next video.